Hello everyone. In this video, we cover the variance expressions of the present value random variable for life annuities. Here we express the variance formula in terms of life annuities. Consider the whole life annuity deal. We have the YZ relationship, Y equals 1 minus, and this expression corresponds to the present value random variable for whole life insurance. So we have the YZ relationship, 1 minus Z over D. Taking the expected value for Y, we have this relationship, and then the variance of Y in terms of insurance. And here we will express the variance of Y in terms of the annuities. We have the relationship linking the insurance AX and the annuity deal A double dot X, and the corresponding second moment pre-superscript AX equals to this expression. And the pre-superscript D corresponds to the rate of discount at double force of interest. Plug in the expression, these two expressions into the expression for the variance of Y. Upon simplification, we get this. The variance of Y in terms of the annuities. Consider the whole life annuity immediate. If the individual dies at this time point, we get this payment if this is an annuity deal, and then the payment stream for the annuity immediate, we have this pattern. The relationship. Here, the only difference is the first payment of 1. Therefore, we link up the two random variables, Y asterisk, the present value random variable for annuity immediate, which equals Y minus 1. Taking the variance on both sides, so the variance of Y asterisk equals to the variance of Y. And we get the variance for the present value random variable of a whole life annuity immediate. The variance is the same as the variance for the annuity deal. Consider the N-year temporary annuity deal. A very similar setup. The YZ relationship. And here, the random variable Z. This corresponds to the present value random variable for an N-year endowment insurance. We still have the YZ relationship, Y equals 1 minus Z over D. The expected value for Y, and then the corresponding expression for Y in terms of the insurance. And then we have the relationship between the N-year endowment insurance and the N-year annuity deal. Plug these expressions into the variance of Y, and then we get a very similar expression here. We simply replace the sub X in the formula for the whole life annuity deal with the notation X colon angle N. All right, for the N-year annuity immediate, if the individual dies within the N-year period, then we have the pattern for the payments. And here, we can still have this relationship. Y asterisk corresponds to the present value random variable for the annuity immediate. equals y minus 1. Y is the present value random variable for the corresponding annuity due. However, if the individual dies beyond the n-year period, we have this payment patterns, and this relationship does not hold. All right, to make use of such relationship, here we make another payment of 1 at time x plus n for the annuity due. And this corresponds to the n plus 1 year annuity due. And I use the notation y and then sub n plus 1, denoting that this is the annuity due for n plus 1 year. And then no change for the payment for the annuity immediate. I use y and then sub n, denote the n year annuity immediate. And here for annuity immediate, I use the asterisk. All right, then the difference between these two annuities is the first payment of 1. Therefore, we have this relationship. Yn asterisk equals yn plus 1, the n plus 1 year annuity due, minus 1. Take the variance on both sides. We get the relationship. The variance for the present value random variable of an n-year annuity immediate equals to the variance of the present value random variable for the n plus 1 year annuity due. Let's move on to continuous annuity. Similar setting, the YZ relationship for whole life annuity. And we'll still get the same expression, y equals 1 minus z. And for continuous annuity, we divide this by delta. The expected value for y, and then the corresponding expression for variance of y. Express the variance of y in terms of the annuity. Make use of these two relationships. Plug this into the expression. Upon simplification, we get the expression for the variance of y in terms of continuous annuities. For n-year continuous annuity, the process is exactly the same. Here z equals e to the minus delta and then times the minimum of tx and n. This is the present value random variable for the n-year continuous insurance. The expected value for this, and then the corresponding expression for y. Expressed in terms of the n-year annuities, we get this expression. All right, these are the expressions for the variance of annuities. And in fact, we don't need to memorize the expression in terms of annuities. As long as we can get the expression between the annuities and the insurance, then we can directly calculate the variance of annuities in terms of the insurance. And then for the annuity immediate, remember the relationship. For whole life annuity immediate, the variance is equals to the whole life annuity due. And then for the n-year annuity immediate, the variance equals to the n plus 1 year temporary annuity due. Let's take a look at some examples. Let y be the present value random variable of an n-year temporary life annuity of 1 per year, payable continuously as long as the individual survives. You are given these three quantities and determine the variance of y. All right, here I will make use of the relationship between the small a and the big A. So I have the variance of y equals to 1 over delta square, and then the variance of z. And z corresponds to the n-year temporary insurance. So we have these two relationships. We have delta equals 0.065, and then the n-year continuous annuity 4.9. And then for the second moment of this insurance, we have 1 minus 2 delta, and then times this. This is 3.6. And then delta is 0.065. From here, we get the variance of y. You can do the problem in terms of the annuities if you can remember this expression for the variance. And then this one is straightforward. Just substitute the numbers. And then we get the same answer, 15.99. All right, the next example. A 30-year annuity immediate, and given that the annuity payment is 100, and then 4 quantities. The actuarial present value of a 30-year insurance, 30-year term insurance, 0.1443, and then the corresponding second moment, 0.0694. Survival probability 30px is 0.7 and interest rate 5%. Calculate the variance of this annuity. All right, the notation for y, 100, the annuity payments, and then times the notation for the 30-year temporary annuity immediate. All right, to get the variance for annuity immediate, we can link this up with the variance for an annuity due. And here a 30-year temporary annuity immediate, the corresponding variance is equal to the variance to the present value random variable of a 31-year annuity due. And therefore, the variance of y is the variance of the 31-year annuity due. So we get this expression. We need to get the present value for a 31-year endowment insurance. And we are given the quantities in terms of the 30-year term insurance. So this gives us the hint that we need to split this insurance, the 31-year terms, in 2 parts. The first part, a 30-year term insurance. The corresponding actuarial present value, we have this notation. And then the second part is a payment of 1 at this time point. As long as the individual survived beyond age x plus 30, then this payment of 1 is certain. And therefore, the probability of having this payment of 1 is 30px. And the corresponding actuarial present value of this payment of 1 is nu 31 times 30px. And we get the relationship. And then the second moment, you simply change the delta to 2 delta. And then we get this expression. All right, we get all the numbers. The 30-year term insurance, 0.1443. U to the power 31, we have the interest rate. And then 30px, 0.7. For the second moment. Plug these two numbers into the expression, and then we can get the answer for the variance of y. And this completes the problem. All right, that's it for today's video. Thank you for watching, and see you in the next video.